Okay, why don't we get started? I don't know if we're gonna get anyone else here today. Um, so it's Thursday. We're just gonna do a little, spend a little time doing discussion about this. I thought um I would have you just share something from your QQSP. So why don't you, if you're here, just find your discussion post and be ready just to share something from that in just a sec here. Um, and then we're going to work on this worksheet. Um, again, we're getting into areas where we're getting to do a lot more coding and trying out stuff. So a lot of this is to run this different code and see it prints out and then modify it or explain it in different ways. Remember, so in the library or in the thing, there'll be links to different environments where you can run and compile, this code in, if it's Java or TypeScript or C, whatever you need there. And you can also have your favorite compiler or whatever. If you want to use NetBeans for your Java, feel free to do that also for this. But this provides just a quick way to do these in the browser, I think, here. So why don't we just do discussions and we'll break up into pairs and so that you get working on the worksheets here. No, turn this around here. This. So we want you to share something from your QQSP unit 6. So why don't we just go through and do that? Talk about that. So Addison, what did you want to share?
Yeah, I have a question on what is the difference between a null pointer and an angling pointer, and why is it important to distinguish between the two when debugging for each?
Yeah, so null pointers versus dangling pointers. So do you have any ideas what
Yeah, I got a comment on it.
Yeah, what was the comment?
Yeah, shit. Null pointers, they're like predictable crashes and when you're like running code, while dangling pointers can be unpredictable behavior, like data corruption, making them harder to decode.
Yeah. I think maybe a more specific definition would be like a null pointer is a pointer that's like set to 0. So it's pointing to nothing, actually the 0 spot or something like that. So it's actually null or empty, or 0, something like that. Depending on the language, some languages have an actual like null value, but other languages like C, a null pointer is its value is just 0. They don't have an actual null value there.
And there's like languages like Java's like assumes you're using null.
Yeah, Java I think has an actual null value for a pointer, so you get there. So yeah. Where dangling pointers are, again, pointers usually point to something and then you accidentally remove that thing. Or, so like, kind of maybe a scenario where I've seen it used is, let's say you have a global variable or a static variable, and then you call some method and you declare a variable in that method, a local variable just in that method there. And you then take your static pointer and you point it to that variable so that you can use it in other places in your code and stuff like that. But then your method ends, and with your method ends, garbage collection should free up all the local variables. So it will free up that variable and what's stored in there, that memory address. But you still have some static pointer that's pointing to it. And a lot of compilers won't catch that. And so if you try to, and then that's now available. So maybe some other party, when you call some other program or some other method, they will use that memory up for a different variable or an array or something like that. And then if you try to reference to this static variable or global variable, that object or that value again, you're writing to some memory location that's not reserved anymore, but has been reused there. So again, to me, a dangling pointer is something that's pointing somewhere that's kind of lost now. Does that make sense?
Yeah.
Yeah, so that, in my mind, that's the difference between the two. I mean, I agree that dangling pointer, a null pointer is, when you look through your code or you print off a pointer or something, it'll be null. It'll be, pretty clear. Where a dangling pointer is often pointing to memory. And what often happens is that you might reference it to the static variable and change it, and it'll work just fine as far as that goes. But then now this part of memory maybe have been changed. So some part of your array or something else has been changed. So all of a sudden, some other variable or something else has been corrupted somewhere else in your program by this dangling pointer. That's an interesting topic. All right. Ready, Grace? So what do you want to share? Yeah. Do you have any ideas on that or?
I have some ideas.
Uh-huh. What did Matt say?
He said that type erasure is a process about the word generic type information is removed from the compile time, meaning activity of the
Right. Yeah. Right. And again, I don't understand type erasure that much, but from what I understand, it's kind of like what he describes that when we're trying to compile it, or if we put in a type in it, but we erase to see if it's consistent, and then we erase that type before runtime. So like we have a kind of a temporary type we use in there. So, yeah, I think it's like that. But yeah, I don't really understand. I have trouble understanding type research. That's a very good question. Okay, hey, Jeffrey's here. Yay. So we're just asking each person to share one of their QQSP talking points or whatever your question or your prompt or something like that. So why don't you find yours and be willing to share that in just a second here. So and again, we're going to do this then we're going to work on this learning activity. And then there's also a short assignment for this that will be here. The assignment lets you kind of play with this idea of reference types and some problems you can get into when you pass an object to a method in Java, and how you can change the original object. And in some ways you can maybe try to write your code more safely so that you don't accidentally change objects when you don't want to change them. So, okay, so Jeffrey, you want to share something from your posting?
Yeah, the question has when should I use smart pointers in C++ instead of raw pointers?
When should you use what?
Smart pointers in C++ instead of raw pointers.
Okay. And what do you mean by smart pointers, I guess, in C++? I can't remember what those are. So I know in C, you have to use pointers directly. You have to have your memory directly. But again, in C++, you can declare a parameter as a pointer, and then you can pass a variable, and it'll automatically convert it to a pointer for you. when you pass it, is that, do you think that, is that kind of what you're thinking of, or?
The smart pointers, help manage memory automatically, prevent memory leaks.
Okay. Right. So yeah, did you find anything else about that? Maybe, again, I'm not too familiar with that term, so.
Found that, you should use smart pointers when needing automatic memory management, when you want to share ownership of an object, or you need to prevent dangling pointers.
Right,
And then, you should use raw pointers when you don't own the object, when performance is critical and when interacting with, C code.
right,
So like C
okay,
APIs use raw
Yeah.
pointers.
right, yeah, so I think that's what it kind of, it's getting at, is that there's some stuff built into, because in C, you could get yourself in trouble so fast, they tried to make it a little easy, less trouble, error prone in C++. So if you sent a pointer as a parameter to a function or a method, you just declared a method, and then you don't have to, again, actually extract the pointer and do it that way. So yeah, I haven't programmed in C++ in years, but I remember when we moved from C to C++, that yeah, the way they did pointers were a lot less error prone for it, but still let you get to some of this mission, this speed critical, or these weird things. You can still do some really low level stuff in C++ there that similar to what you could in C, but I thought was just a little more safe. So but again, if you're dealing with C libraries and like that, you do have to use those old C operators. So. Okay. Eva, are you online? Are you hearing us? You want to share something from your stuff? Okay, wait, I put those stars by Jeffrey here too. Okay. Yes, you can type your question. I guess. Let me pop up the chat. Okay, he was gonna type her question in. Oh yeah, how can C be used to or pointers be used to optimize memory usage in programming languages like C for this? Always think of this more like as, like if you're like on a little embedded hardware and you don't have much memory and you're trying to optimize, or that's where I see it, because in the old days we did this all the time because all of our hardware was small and we never had enough memory to do this sort of stuff there. So like in a video game, you were if you're trying to work with graphics or an image or something like, or display a sprite on a screen. So you had a memory area where you had the pixels for the screen and you had your sprite and you were trying to animate or move that sprite around the screen. You could rather how you could write specific routines of how you would copy these pixels from the sprite onto the pixels on the screen and do it so that it fit your sprite exactly and kind of optimized it so that if you're sprite was only 16 by 16 pixels or whatever, that in memory you have multiple copies of that. And again, sometimes you could get this with a two-dimensional array, an array of arrays here, but again, sometimes it was faster to just declare the memory and write the routine, that knowing what size the memory was and where every byte was and how the bytes were used there. I guess in my mind, that's where it's used, when you have specific like little data structures and you're trying to manage those in a very optimized way. For often like not just like 32-bit integers, but you're working with 8-bit in it, or smaller bytes or something like that, and memory locations for this. I'm not sure how AI can assist in detecting memory problems other than just normal. I mean, I think AI is good at generating this stuff in general. I don't know if it's better at finding memory leaks than anything else. I've been impressed lately in the new AI models that do reasoning. I don't know if you've used any of the new AI reasoning models, but I've been finding, I use ChatGPT, and I haven't just used, what is it, 4.0, the free model for lots of stuff. But then I noticed when I get to a harder coding problem and it doesn't work, I then switch to the new, I think, 3 mini. The reason it's a reasoning model, and I paste the code or the question, same prompt in there, and it actually reasons. So it'll work through a set of reasoning questions, or and it shows kind of its work as it's going, and then it'll come in a solution with it. And I'm finding better results. So if I get a bad result on the normal free model, if I use that, I have a paid subscription right now at ChatGPT, and I can have access to it. I don't know if everyone does, maybe. But I found just the reasoning models are better, are getting better than the standard models. They're slower, but again, for the hard problems. All right. Okay, I'm gonna put Eva's name on the list here. Okay. So let's break into pairs. And work on this stuff. So again, we're gonna we'll have you work through this worksheet here for that. We'll break you up into teams, and you can do this. Again, if you're asynchronous, we'll assign you to pairs. And what I generally want, what you can do with this, and I've kind of done this initially, is highlighting in colors what each person will be working on here. I think it's nice if you are here together just to ignore the colors and just work on it together and stuff, and do that. I left some things in gray that either student could do for this. So let's just break you in teams here. It looks like Grace and Addison were last time. Grace, Heba's online. Do you want to work with Heba? You want to jump on Zoom and work with Heba? Okay. So we'll get Grace and Heba together, and then we'll get Addison and Jeffrey together here. And we'll kind of randomize some of these other. I'll create a breakout room. Well, even Grace, if you want to jump into a breakout room or just use this main room, whatever, or just mess it, I don't know how we want to cooperate or whatever, but you can decide that. Okay. You have options now. All right, I'm going to stop this recording then for a bit. Okay, I'm going to break in just a little bit, check on a couple things. First, how's this exercise going? You running into any issues with it? Code not compiling or anything like that? You're able to run the code samples. One of the things I think that's nice about this class is we get to try to kind of play with the same code in lots of different languages. I'm trying to figure out how best to do that. I was just thinking, as I was listening to some of you divide up on team or team assignments here, with this. I actually originally had kind of color coded this so that one person would do this Java one, another person would do the Python one. But I actually think, I think what someone else did is that it almost would be better if someone just did part one, and then you got to see the Java and the Python and the JavaScript all related to each other. And another person did part two, where you got to see kind of the similar code here. So I think, again, one of our goals in this class is to get you looking at the same code in multiple different languages and get kind of used to that. There. So, okay, the other thing I just wanted to check is that yesterday was the Minnesota Private College Job Fair. Did anyone go down to the job fair here? No one's looking for a job or anything like that? No one went to the job fair? Nope. Okay, you don't need jobs. Eva, did you go to the job fair? I don't know if her volume's working now. She was having issues earlier. So, okay. Well, I haven't heard a
I
report
did.
on how it went. What?
I
Are you
did.
there? Eva, did you go to the job fair?
Yes.
How was it?
It went pretty good.
Doesn't sound that exciting. Did you talk to any new companies or anything like that? Okay, I won't put Eve on the spot anymore, I guess. So, all right. Well, I'll let you keep working on this, and let me know if you have any issues. And remember, the assignment is due this week. And again, it's similar, it just looking at a particular issue with Java and how you can address that.